Earth that doesn't spin underneath, a non-Coriolis effect, no deviation, a la SciManDan with a tractor pulling a trampoline and a man bouncing up and down and not drifting. You put a drone on a roundabout with a little mark on the roundabout. You spin the roundabout and launch the drone. Once it leaves the roundabout, the drone just hovers in midair and the roundabout spins underneath it. Now, if this effect of being on the roundabout, you now as an individual with eyes on the roundabout, looking at the drone that's just hovering above it, but the roundabout seems to go towards you, and then come away from you, go towards you, come away from you, because you're spinning underneath it. Now, it is just hovering, but because you're moving underneath, you see this apparent deflection. It seems to come towards you, and it seems to fly away because you're spinning underneath. Now, if that effect, that apparent deviation, is true on a roundabout, because that is Coriolis effect, and that's translatable to a spinning Earth, then all you need to do is launch a drone off the Earth. And the moment you do, it has, like with the roundabout, left a spinning reference frame. And when it does, you'll watch it seem to drift away from you. Now, it isn't really drifting away from you, it's just hovering. But the ground you're standing on is claimed to be moving underneath it. That's what gives you Coriolis effect. So for there to be a Coriolis effect on Earth, you would launch a drone, and on the equator, you'd drift away from it at 1,000 miles an hour. Obviously, this does not happen, because the Earth isn't rotating underneath anything. But you can definitely demonstrate a Coriolis effect, launch something off a spinning, rotating platform like a roundabout, and watch it seem to come towards you, come back, seem to come away from you, come back, while it in reality is just in midair hovering. But because you're rotating underneath on a roundabout, it seems to deviate. And on Earth, because you're claimed to be on a spinning Earth, you'd launch a drone and it would seem to drift away from you. Obviously, it's just hovering in midair and the ground's rotating underneath. Now, if that was the case, a drone isn't needed. Flight times would be massively reduced when travelling west, because the Earth's moving underneath those flights. Flight times aren't reduced because nothing's moving underneath any plane ever, or any drone ever, or any ball, or you if you jump up and down. Nothing's rotating underneath when you leave Earth, when you leave the ground. So yeah, 2 centimetres above the ground with a drone, you should see it drifting, because there's claimed to be a Coriolis effect on Earth because Earth rotates underneath. That's what Coriolis effect is. Now, as soon as you get that very concise explanation of Coriolis, they will convolute it with 2 different things. 1, Earth that doesn't spin underneath, a non-Coriolis effect, no deviation, a la SciManDan with a tractor pulling a trampoline and a man bouncing up and down and not drifting, not deviating, returning to the mark underneath. If you put an X on that trampoline, he's hitting the X each time. Whereas with Coriolis effect, when you launched your drone, the X span underneath it. Deviated from that position that was marked. So they'll argue about there being no deviation, in other words, a lack of Coriolis effect, as a defence. Well, we wouldn't see the planes with Earth spinning underneath. You're like, well, how can you start an argument that's for Coriolis by declaring that you won't have the effect because you haven't got the Earth spinning underneath? They claim Earth and atmosphere travel as one. So that's their first defence. Say that you've only got one reference frame. Their second defence is to convolute the rotating frame of reference with something we actually observe. So in the example with the roundabout, the rotating frame of reference is the roundabout itself. And the effect observed is you still sat on the roundabout as it rotates. Well, they will confuse and convolute that rotating non-inertial reference frame, in this example a roundabout, with something like a hurricane, which has an actual rotation direction. So in your drone example, the drone leaves the roundabout. It's stationary. In its general position, it's not moving left or right or up and down. It's just hovering. But the roundabout spins underneath. That's the thing with the spin direction. Where you're sat observing the drone from spins under the drone. So the drone hasn't got any movement. It's appearing to deviate because you're spinning underneath it. That's Coriolis. So when you see something in the sky, not a drone in this example, but a hurricane that's actually spinning, unlike the drone, your drone wasn't spinning above the roundabout, to give you Coriolis example. You were spinning underneath it. But they talk about hurricanes like they've somehow got something to do with a Coriolis effect that's observed from the spinning frame of reference. So in their example, when they use hurricanes, unless you're actually being swept up in the bloody hurricane, observing something on the ground that seems to deviate, but it's stationary, and you're moving in a sodding hurricane, there's no way the spinning reference frame of a hurricane's ever going to be useful for demonstrating Coriolis effect. Because you're never going to be in that position in a hurricane, spinning around and around and around in the air, observing something actually stationary seeming to move. It's preposterous. But by convoluting the two, you could easily confuse an audience member and easily bamboozle your opponent. Because most of the time, the people arguing against this on our side don't know what Coriolis effect is either. So they're like, well, what is Coriolis effect exactly? It's like, yeah, you need something to be spinning and then leave it or be in the air, and you observe it seeming to drift when it's going straight. Well, a hurricane doesn't conform to that. It's actually travelling in a circle. So you seeming to see it travel in a circle from the ground that's spinning, that would be Coriolis effect. But then you end up with someone like Kosho saying, yeah, that's right, because that's what Coriolis effect is. Therefore, the wind's travelling in a straight line. Because their doublespeak make no sense. They don't have an Earth that spins underneath anything. Earth isn't spinning.
Then when you get your ass handed to you, Georgie Tatanka, he then says that third thing, whether it be a drown, bullet, is the third reference frame. And says, yeah, it's the third reference frame. It's going through the atmosphere. Is it in the atmosphere? Yeah, that's the second reference frame. No, that's the third reference frame. And you forgot that the Earth is spinning underneath the roundabout. I mean,
wow.
Carnival tent bozos.
He said that.
Hold on, there is something to add to that. There's a method in their madness. The whole point of this, even though it can be unpicked and understood, and is actually relatively simple when you get down to the bare bones of one rotating reference frame and one non-rotating reference frame, the simplistic nature of Coriolis isn't actually that complicated. It is if you wiki search it, though. You'll come across a lot of nonsense about what Earth's supposed to be doing. That being said, the whole point of this convolution is every step of the process for a globetard will be to beg the question that Earth is spinning at some point in their examples. So with the third reference frame, oh, well, it's Earth spinning underneath, because every point in the argument just has to have the affirmation that Earth's definitely spinning. Doesn't matter if they're arguing that you won't see deviation, because Earth is spinning with the atmosphere, or you've got a roundabout with a ball being thrown, and that's two reference frames, plus the Earth spinning, because we've got to beg that question, or a declaration that we don't see any deviation ever. Like we wouldn't see any deviation on Earth that's spinning. Well, that's not Coriolis effect. But all of them can be picked apart. They all just take the same route, which is to, at nausea, beg the question that Earth's always spinning in every bloody example, regardless of what's being argued for. Coriolis effect, no Coriolis effect, things moving with the Earth, things not moving with the Earth. So long as they're always barking on about it bloody spinning, no matter what the example, then they're happy. Because all the audience hears is lots of times that they say, well, because Earth's spinning, well, the third reference, because that's a spinning reference frame, Earth, that is. As long as they say that a million times during the confusing bullshit, people at the end of it will be confused about what Coriolis even is, but have been told 20 or 30 times that Earth's spinning. It isn't. Or you'd have a Coriolis effect.
Spinning first.
Yeah, you got it.
Assert that a hurricane is created by the Coriolis effect. You might not want to use a citation that defines the Coriolis effect as an illusion. Because then you're going to have to explain how an illusion created an actual storm. Thank you.
The stupidest one for me, you got grown adults telling you that the atmosphere, which is made of gas, has no intermolecular bonds with itself or anything else, is traveling along with the Earth. That has to be the gosh darn it stupidest thing I've ever heard. East, north, and south surface winds disproves your nonsense, even if you don't know what gas behavior is, and you don't. You don't even know what gases are. Clowns. This is a clown show. Carnival tent.